So number 23, we have a quadratic inequality, and we haven't really worked with quadratic inequalities much. It's the same thing as a quadratic equation. So you could technically pretend for a little while that that inequality is an equal sign, and you want to set it equal to 0, so go plus 6, and you're going to have 3x squared minus 9x plus 6, and we're just going to pretend that it's an equal sign. 0. Now this is all the terms have a multiple of 3, so you could divide everything by 3, and you're going to get x squared minus 3x plus 2, and again that's a pretend equal sign. But if it were an equation, then you could factor, split, and solve. Of course, you could always use the quadratic formula on any quadratic equation. Your a value is 1, your b value is -3, your c value is 2. You could even go back with the a value of 3, the b value of -9, the c value of 6. Using the quadratic formula, it would give you the same answers anyway. But since I know I could actually factor this, I might as well factor it. What do I mean by that? Parentheses equals 0. What times what is 2, that if I add together is -3. Well, that would be a -2 times a -1. And if I split it, x minus 2 equals 0, x minus 1 equals 0. If I split it and solve, I get x equals 2 and x equals 1. Now, those would be the answers if it were a quadratic equation. But it's not a quadratic equation, it's a quadratic inequality. So what's the difference? Well, if you talk about equal signs, it's talking about specific values, x equals 2, x equals 1, but when you deal with inequalities, you're talking about an area of answers. So what we need to do is realize that these answers are our critical points. So we're gonna move to the side over here and go to a number line, and on that number line I'm going to put these points 2 and 1. And what we need to do is realize that our answers are either going to be on the outside or on the inside of this inequality answer that we have. Okay, I know this might sound a little confusing. What we need to do is test values. So what do I mean by test values? I need to pick a number. So I want to test the number 0. Okay, I want to test this number right there, 0. So let's see if it works. So in order to test 0, all you got to do is go back to your original inequality, the original one, and plug in 0 for x and see if it gives you a true statement. So you have 0 squared times 3, that's 0. 9 times 0 is 0. So this whole thing is 0. 0 is less than or equal to -6. So what do you think about that? Is 0 less than or equal to -6? No way, 0 is greater than any negative number, so that didn't work. So what do we know about that point 0? It didn't work. It's not an answer. Okay? So this side over here is a no. Okay? It's no, it doesn't work. Okay? So knowing that it doesn't work on the outsides, it must mean that it works on the inside, but still let's test. Okay? Let's test a value like over here that's on the outside. Like let's test the number 3. Okay, let's test the number 3 to see if it works. And how am I going to do that? I'm simply going to plug it in right into my x values. Whoops. Sorry about that. We're going to plug it in right into our x values right here and here. So let's plug in a 3. So I want to rewrite this whole thing, but with 3's instead of x's. And I want to do that over here on the side. So again, I'm going to test the value 3. Let me plug in 3 into those parentheses. Let's see what we get. See if it works. Plug in a 3 right there and a 3 right there. You're going to get 9. That's 3 times 9, which is 27. Minus 27 is less than or equal to -6. 27 take away 27 is 0. 0, is it less than or equal to -6? 0 is not less than any negative number. So what could we say? That this answer 3 does not work either. So up on my number line, this one did not work either. So my answers must be in between these two values. Okay? So how are we going to write the answer to this inequality quadratic, we are going to write it as a compound inequality. And we're already used to doing this. You put the x in the middle, you put the 1 on one side, the 2 on the other, and less than symbols on both. And because the original had or equal to, we are also going to put or equal to. So this is our answer to the compound, the quadratic inequality that we had at the original, which is over here. So to sum things up on number 23, I would like to give you the explanation here. You solve quadratic inequalities the same way you solve quadratic equations. The only additional step you have to do is place your answers on a number line and test your values to see if they're on the outside or the inside of your critical points, which are your answers. And then you write it as a compound inequality with the x in the middle, or separate with the word or. So on the example that we just did, number 23, we got a compound inequality because the areas were together. So let me just do one random or a different example of them where they're apart. I want to write a quadratic trinomial that I know could be factored. Let's say 1x minus 6, okay? And let me put a greater than or equal to symbol with the 0 right there. So if it were a quadratic equation, you would just use a quadratic formula, or you could try to factor, split, and solve, which you can do. So I'm going to factor. I'm going to pretend it's an equal sign. And what times what is negative 6 that if you add together is negative 1? Negative 3 and positive 2. So we're going to split them and say x minus 3 equals 0 and x plus 2 equals 0, which means that our answers are negative 3 and positive 2. Let me scroll this down. So my answers are x equals 3 and x equals negative 2. Now, if it were an equation, if the original were an equation, I'd be done. But it's not an equation, it's an inequality. So like the instructions said above, the only difference is that you have to make a number line and put those answers on a number line. So the negative 2 is over here, the positive 3 is over here, the 0 is somewhere in between. And now all you got to do is test the negative 2 and the positive 3. Not test the negative 2 and positive 3, but test values that are on the outside and on the inside of these critical points of these answers that you got. Okay? So these were the answers. I just put them on a number line. Now I'm going to test. All right? Now I'm going to test. What am I going to test? I want to test a number like negative 5. All right? I want to test negative 5, which is clearly on the outside of my blue dots. Right? So I want to test negative 5. If I plug in a negative 5 right here, negative 5 squared is positive 25. Okay? Let me write that down. Positive 25. And if I plug in a negative 5 right here, it's going to be negative 1 times negative 5. That's also going to be a positive 5. And at the very end, minus 6. Now the question is that greater than or equal to 0? And the answer is yes. 24 is greater than or equal to 0. So when I test negative 5, yes, it works. Okay? So negative 5 does work. So the outside is an answer. Okay? Now that means if I test 0, it's not going to work. Right? 0 is in the middle. If I plug in a 0 right there, 0 and 0, it's going to say negative 6 is greater than 0. Negative 6 is not greater than 0. Negative numbers are not greater than 0. 0 is greater than any negative number. So 0 did not work. 0 would be a no. It's not an answer. It doesn't work. So yes out here, the answers are on the outside. No, the answers are not on the inside. And on the other one, if you test a value out here, like let's say positive 5, let's test positive 5. We could do this in our head. Test 5 right here. It's 5 squared. That's 25. Minus 5, that's 20. 20 minus 6 is 14. And 14 is definitely greater than or equal to 0. So that'll also be a yes over here. So where are our answers at? They're on the outside. Our answers are not on the inside. It said a no when we tested the inside value, but it's yes on the outside. So the answers are on the outside. I need to write these answers as a compound inequality, but separate with the word or. So you're going to say x is less than or equal to negative 2, okay? Or x is greater than or equal to 3. And that's the multiple choice answer that you're looking for on the test. So I hope this helps, guys. If you get your answers and you test the outside and the answers are on the outside, you have to write it separate with the word or as inequalities. And these are or equal to's because the original was an or equal to. If you test the inside and it works, then it would be a compound inequality together. So you would have to write the compound inequality together, kind of like the way we did on the test, on the practice test over here. So you see right here, it did work on the inside. Yes, the outside did not work. That's why we wrote it as a compound inequality written together up here. Okay, so let's delete one of these because 25 doesn't work out the way I wanted it to. Let's just delete it, okay? So going back to number 24, you're going to use the quadratic formula. And of course, we're going to replace the variables with parentheses. And we're going to plug in the b value, which is 6, the a value, which is 7, the a value, which is 7, and the c value, which is 2. And we're going to work on the discriminant value, the inside of the radical. We're going to start on that. So we're going to have I want to move it up here. The square root of 36 minus 4 times 7 is 28. 28 times 2 is 56. 56. And of course you have the plus minus in the front, the negative 6, the divided by, and the 14 on the bottom. So 36 take away 56 would be a negative 20. So we have negative 6 plus or minus the square root of negative 20 over 14. And from there, we could actually simplify the square root of negative 20 on the side. So the square root of negative 20, the negative becomes an I on the outside, and the 20 becomes a 4 times 5 on the inside. So you have an I on the outside, the square root of 4 with the square root of 5, which is going to be I times 2 times the square root of 5. Again, the square root of 4 right here, the square root of 4 is 2, no more square root. So you really just have 2 times I times the square root of 5, and you might as well write it as 2I square root of 5. 2I square root of 5. So I want to replace this guy with the square root of negative 20. So I have negative 6 plus or minus 2I square root of 5 over 14. Now notice that all three terms, 1, 2, 3, all three terms are divisible by 2. So you might as well reduce everything by 2. You're going to get a negative 3 out here. The 2 completely cancels out. It's just going to be an I. And the 14 on the bottom becomes 7. So we're almost done here. Our answer so far will be negative 3 plus or minus I square root of 5 over 7. Now because there is an imaginary value, it's a complex number, which means we need to write it separate. So our final answer is going to be negative 3/7 plus or minus the square root of 5 over 7. You split the denominator to each. And notice that I took the I and put it way at the end outside behind the second fraction. That's how it's going to appear on your multiple choice answer.